Hello, welcome to the Optio Drive Assistant tutorial series by Infranor. This video assumes you have watched the previous videos in the series. Today, we are going to walk through the wizard and cover operating voltage and motor configuration. Let's start by launching Optio Drive Assistant. Now, we can start a new project with auto detection. First, we are going to verify the port and the baud rate, then click Detect. This detects all the devices that are connected currently, and once you see the servo drive, you are ready for the next step. Click on the star icon to start the wizard. Then click on our drive. We can proceed to the next step in the wizard by clicking the arrow in the bottom right corner. This is our device properties page. Here we can find the information that is being read from the drive. Let's proceed to the next step by clicking the arrow. This is our power supply page. Here we can configure our operating voltage and fault conditions related to voltage. Our drive runs at 230 volts AC and has an internal braking resistor. We can find additional wizard help here by clicking on the question mark. This page gives us an in-depth explanation of our fault conditions. For example, we can set the threshold for operating voltage. This will trigger a fault if the voltage changes from our predetermined value. We can set this threshold in the Advanced tab. Additionally, we can control braking resistor operation and when we want warnings to be triggered. Let's click Apply to confirm these settings. Then click the arrow in the bottom right. Let's go to the Help menu to see more details on what we can configure. We have three main sections on this page: Motor Catalog, New Motor, and Advanced. This page gives us a detailed explanation of how to configure these settings. Let's start by opening the motor list. Here, we can find an existing list of Infranor motors that have already been configured for use. Now we are going to find an FP motor. For our example, let's select the FP0023 with a 48-volt winding. Then click Apply. We can now verify that the motor is registered with the servo drive. Next, we can edit the parameters of this motor in the Advanced tab. The motor we selected from the list has resolver feedback as default, but the motor we are using has an incremental encoder with Hall effect sensors and a line count of 1024. This can be different depending on the motor. Additionally, there is an option for motor phase search on first enable, and you would use this if your encoder does not have Hall effect sensors. We are going to click Apply to confirm these settings. Now, we are going to auto-calculate our drive current loop gains. In our example, the motor inductance was auto-populated based on the motor we selected, and we use this value to calculate the gains. Also, we desire high performance or a high current loop bandwidth, so we've selected the high bandwidth option from the pull-down menu. Now press the Compute Gains button. Here we can determine our motor protection via temperature sensor. We are going to leave this as is. We can also change our I2T conditions, which tells the motor how to control the current during an I2T fault. Fusing is for a hard fault, and limiting is to fold back the current to 80% of rated current. Now, we are going to auto-phase the motor to calculate our feedback offsets. Let's start by clicking Start AutoPhasing. We may receive an error if we recently changed our feedback type, so click the check to proceed. We have now auto-phased the motor and calculated our feedback offsets. If we are adding a motor not found on the list, we can complete these same steps inside of our New Motor tab. Inside of the New Motor tab, you can enter your motor datasheet information as shown here. This concludes part 1 of our wizard walkthrough for the Optio Drive Assistant tutorial series. In the next part, we are going to cover specifics on setting up the controller. Thanks for watching. Feel free to check out our website at infranorusa.com.